Okay, so the final topic we talked about in class was phonation. So we talked about a lot the larynx and the trachea and the relationship between the two, where they're located. So the larynx sits at the top of the trachea. So the trachea is on the top, the larynx is below it. So the larynx is also located between the C3 and the C6, which are the trachea and the hyoid bone, as well as it houses the vocal folds. So additionally, respiration and phonation are extremely important in the process of the speech chain. So respiration is the source of energy for speech. So that allows you to take a deep breath in before you exhale. So it makes sure you don't run out of energy. So if you take a smaller inhale, it would be harder to speak on the exhale. But if you take in more of an inhale, it's easier to speak on the exhale. Then we also have phonation. So phonation discusses the source of voice for speech. So this makes sure you do not run out of breath right when you speak. This is from the Anatomy of Phonation PowerPoint. Additionally, something that's very important is the intrinsic muscles and the cartilages associated. So intrinsic muscles are muscles that have both the origin and the insertion on the laryngeal cartilage. Not one is on and one is off, they're both on the laryngeal cartilage. So they make fine adjustments to vocal mechanisms, and these muscles are abductors, adductors, tensors, and relaxers. So on October 23rd, we discussed what the abductor muscles were in class. So the abductors are the lateral cricoarytenoid, the transverse arytenoid, and the oblique arytenoid. And then the adductors, it's just one, it's the posterior cricoarytenoid. Additionally, we talked about tensors, which, as it sounds, they just tense the vocal folds. So these are the cricothyroid, this consists of the straight part of it, as well as the oblique part, and the thyrovocalis. So the thyrovocalis, we learned this about on October 28th. And the relaxer muscle, which relaxes the vocal folds, is the thyromuscularis. Additionally, we have the stages of phonation. So there's initiation, sustained phonation, as well as termination. So initiation was the first stage we learned about, and initiation is when there's a vocal attack. So the movement of the vocal folds go into the airstream. There's a simultaneous vocal attack, which coordinates the adduction and the expiration, so the exhale, so they occur simultaneously at the same time. Additionally, we have a breathy vocal attack, so this is airflow begins prior to adduction. And then lastly, in this stage, we have a glottal attack, so that's the expiration occurs after the adduction. Next, we have sustained phonation, so this is when the vocal folds are held in place during the sustained phonation through the muscles of adduction. And once again, the muscles of adduction are the posterior cricoarytenoid. During sustained phonation, there's a steady state to control the fundamental frequency. It is not due to the repeated adduction and abduction of the vocal folds, so it is not due to the opening and the closing, or the opening and the closing. It's also a maintenance, or it maintains the laryngeal posture as the vocal folds vibrate. And then the final stage of phonation is termination. So this is when the removal of the vocal folds from the airstream by abduction Once they're out of the airstream, the turbulence gets reduced and the vocal folds stop vibrating with each other. We terminate and initiate phonation many times during our speech, and termination is vibration. It is not abduction or adduction. It is not the opening or the closing of the vocal folds. It is just the vibration of them. Okay, then we have the Bernoulli's effect. So the Bernoulli's effect is a decrease in air pressure and an increase in velocity. So a high pressure and a low speed would open the vocal folds. So then if it's a low pressure, high speed, that would also open the vocal folds. And then finally we have the myoelastic aerodynamic theory, which is the interaction of air pressure and vocal fold composition and the lateral displacement of the vocal fold position. So this also works in hand with the Bernoulli's effect, which once again is the decrease in air pressure and the increase in velocity, and the high pressure and low speed opens the vocal folds.